Hello everyone, my name is Cesar Garcia and I'm here to present a topic about HBase as a real-time column-oriented database. And the way that I'm going to present this is through a project. And the idea of this project is to compute the average limit per country for location in case of a hurricane. So this is like in terms of insurance, what's the limit that they will pay based on the location of the property. And this is important because in the past 15 years, Florida has been hit by several hurricanes that have impacted, obviously, the premiums for insurance policies, especially in 2004, where they were hit by 3 hurricanes, and then in 2005, they were hit by 2 more. The solution for this project is based on 3 stages. The first one is like the data that we have on a CSV file is going to be read, and then it's going to be pushed into HBase. Then we're going to have a Python client that is going to read data from HBase and compute the average per country using Spark. Finally, we're going to visualize the results using Chart.js, which is a JavaScript framework that is so much easier than D3.js or C3.js. As introduction, well, HBase was built to be a distributed database, just like Cassandra. It's extremely scalable and it's based in the Google's Bigtable paper. So they're considering that HBase is considered like the open source implementation of Google's Bigtable. It's a key value pair NoSQL database. So pretty much you have like a primary key and then you have remaining columns, but you are going to query most of the time based on the key. It's very fast for one that reads and writes. So that's why it's been becoming very popular. Real time, there are no MapReduce jobs. And the main structures in HBase are tables. There is no concept of namespace or database, just like in Cassandra. But a new concept that's quite interesting is column families. That means that we can group columns based on how they are related among them. And this is going to help us to improve performance because the physically column families are going to be stored in just one place. Here's horizontal scaling. That means that we just need commodity hardware in order to keep scaling. We don't need like very expensive hardware. Very basic query language, just create, put, scan, get, delete all. It managed version, which is something like pretty awesome, so you can go back in time to like for auditing and see how was the value at a certain point in time. And based on the CAP theorem, they consider consistency and partition tolerance over availability. So they will always prefer to be consistent and partition tolerance, and well, they will sacrifice availability. It's written in Java with clients in different programming languages, just like JRuby. HBase is not a silver bullet, so it's not going to help you solve every problem. We have to be cautious about when to use it. Cassandra is a direct competitor, you can say, but HBase has certain features that might be useful for certain cases compared to Cassandra. No SQL, but you can have SQL type queries if you use Apache Phoenix, Hive, or Impala. No cross-record transactions or joins, pretty much like with any other NoSQL database. So you're going to work mainly on a denormalized table, just like with Azure Table or Cassandra. So compared to other databases where you build your databases and then your applications on top of your database, here you have to build your application and then based on the queries that you're going to use, that's how you're going to design the schema for your database. So the application has to come first most of the time. This is usually used when you need like high write and read throughput. It supports sharding and it's extremely scalable, as I have mentioned. But this is mainly for online transaction processes. It's not to be used as analytic process. So for that, you should use Spark or any other framework on top of HBase. For this project, we're going to see that the Java client, compared to the Python client, is a little more boilerplate, but it's very simple to use. We just have to define a configuration object, and then we can just create our connection. It's very important that we define the client port, and then in our case, since we are just working locally, we can just tell, hey, just look for our database in a local host. But in a distributed environment, this will change to master or something else depending on our configuration. And then we create a connection and we just get a table. The HBase works with arrays of bytes. So everything that we want to push, we will have to convert into an array of bytes. Um, so here also you can see that HBase, the client for Java, supports batching, so I can have like a list of objects and then it can be pushed directly into HBase. To retrieve an object, it's also, as you can see, I have to convert like the primary key into an array of bytes, and then I have to define this family column. And this is important, as you will see in a moment in the shell, because every value in the column that can be schemeless. But for the family columns, I have to define a family column where this column value is going to be put. All the values, since we're pushing it as an array of bytes, then the value that we get is obviously an array of bytes as well. And this is on the client. On a shell, that doesn't happen, but most of the time you're going to work with a Java client or with a Python client. Just like in this case, for instance, if you compare the Java client, I am missing here a lot of code. But with the Python client, this is it. This is all the code to read all the column, all the values for a certain column and a certain column family, and certain column families, sorry. And this is all that is. So in Python, it's very important that you have to start Thrift, which is like an intermediate service that will help us connect from Python, from the HBase driver into HBase. So now I'm going to move on to the presentation. Sorry, before that, this is the charges that we're going to display it. Here you cannot see very well, but I'm going to show you just in a moment how this actually looks like. So very simple commands list actually list our students, and actually I can, for instance, drop a table, but for that I have to disable the table policies, and then once the table gets disabled, let me see if I am not making, oh yeah, it's disable policies. Sometimes it takes a while, might hang. Okay, oh, it looks like it finished for some reason. Oh, no, it did not. Oh yeah, sorry. We have disabled the table policies, but now we have to drop it, so we don't have any problem about some client trying to write. So now I am dropping the table, and then we can see that the table has been deleted. I can scan a whole table just with the students like this. And then something very interesting, if I want to push a value, I can push based on columns. And I'm going to push a value, I'm going to update this value. So whenever you add there, it's just like an observe. So I want to say, hey, I want to put a value into the students table, and the primary key is going to be GarciaVazquez, and then I have to specify the column, which in this case is going to be, let's say, assignment 01, and then the value I'm going to reduce. You can see that we have 100. I'm going to reduce it to 70. So if I now scan again students, you can see that I have this value 70 updated. If the column doesn't exist, let's say 7 for instance, and then I scan again, it will create the column. Otherwise it will update. So this works as an observe. But something very interesting about HBase is that you can go back in time. You can actually tell him, hey, show me how data look like in a certain range. So for instance, you can see that this value was updated at this moment, but I want to see how this looked like before I made the change. So I'm going to paste it. And then I'm going to select one less than. And you can see that at this moment, my value was 100. So it was just 1 millisecond before that. Now, you can see that I have been able to push and get, in order to get a specific column for a primary key, I just select the table, then the primary key, and then the column. In this case is assignment. I can select 01. So I am going to get it at this point. It's very important to notice that I have a prefix for G. That means that G is the column family. This allows me to group columns based on certain category. So now I'm going to run my program. As you can see, I don't have the table policies. It doesn't exist. So I'm going to run the application. And in this case, it's going to read from the CSV file, and then it's going to push everything into HBase. But it's actually here. And run as. This actually takes a couple of seconds, takes around like 10-20 seconds to populate. So meanwhile, I'm going to show the code for Python. The code for Python is extremely simple compared to the code in Java, just pretty much as all the projects that we have done. Let me open it. Documents, workspace. And this is it. So pretty much as you can see, the code is very, very simple. Now let's take a look. The Java code should have finished by now, and yeah, this is done. So now I will come back, and then I will try to list. And then you can see that we have policies, and then we can count how many elements I have in policies. This actually takes a couple of seconds because of the amount of data that I introduced. It's like 36,000 records I have introduced. So 5 seconds is correct. It's about to finish. So I can, so you can see here that the road is displayed in a very weird way. That's because the way that we push data is an array of bytes. So usually the HBase shell is not going to be used to query a lot. This is just more like to understand or take a look at the data. But most of the information is going to be done through. Is going to be done through the client. So as you can see here, we have this client that pretty much what it does is that it reads all the data, but based on the county, which has a column family B, and then the hurricane site limited, which is on a column family L, and then it appends those as everything as a tuple, and then through the magic Spark, then we're going to get the average per county. Let's try to run it and see how we get the data. Well, actually, I already run it. And these are the labels that are printed, and these are the average. So I just need this data to paste it into my code to visualize it. And then visualization is actually pretty simple through char.js. I just need to paste that information here, labels, and then I need to paste the information here, data. As you can see, I am defining some information about the colors. And then finally, this is the code that does all the magic. Here is declaring just a chart, and it's going to be of type bar, and that's it. So now when I am here to display the data, this is it. So pretty much just like 4 lines of code are the ones that I have to use. So everything here is done through char.js. Well, thank you very much.